This is the solution set to the homework from Chapter 1, Section 1. So let's start off with number 11. You were assigned the odd numbers from 11, I believe, until 27, and then you had 27 through 32. So let's look at these questions. First one is birthdays. Birthdays are not evenly distributed across the days of the week. Here are the average numbers of babies born on each day of the week in the United States in a recent year. So you see here you've got a day of the week, and you've got the number of births. So let's look at the questions. Present this data in a well-labeled bar graph, and would it be correct to make a pie chart? So the first thing I'm going to do is I'm going to show you how to actually make a bar graph on the Inspire. So let's look over at the TI Inspire. So the first thing I'm going to do is I'm going to add a list and a spreadsheet. And I'm going to make my first column a categorical variable. You can make categorical variables when you are graphing and entering data into the Inspire. They don't all have to be quantitative and numeric in nature. So let's enter my days of the week. So I've got Sunday, I've got Monday, I've got Tuesday, I've got Wednesday, Thursday, Friday, and Saturday, if I could spell correctly. So those are going to represent my days of the week. So I'm going to go back up to the top here. My second column is going to represent the number of births. Now this is going to be a quantitative variable because it is numeric. So I've got 73, 74. I've got 11,704. I have 13,169, 13,038, 13,013, 12,664, and 8459. So once I've got all these data entered in the calculator, the question is, where do I go? So what I'm going to do is I'm going to add a graph, a bar graph, and I want to show you how to do that bar graph. And we're going to do it the same way we do with all of our data entry, our visual representations of our data for the Inspire, which is to go through the Add Data and Statistics menu. So I'm going to hit Control I. That's your insert function. That's your insert command. And I'm going to go to Add Data and Statistics. Now, once you get to this screen, if you're doing a bar graph or a pie chart, you need to be very careful, because once you designate both axes, it won't let you do that. And I'll show you what I mean. If I wanted to designate this as the day that the births occurred, okay, notice if I hit Menu and I go to Plot Type, look what the options are. Bar chart and pie chart. I've got two options, okay? If I hit Pie Chart, you can see it'll actually create a pie chart for you. And if you mouse over each section, you can see that it has percentages. But what do you notice about these percentages? They're all the same, because what have I not told it to do yet? I've not told it what the frequencies are. It's just going by the day of the week. It has no idea the frequencies. So I'm going to undo that, Control Escape. Let's go back to where we were. So again, I'm going to go to Menu, Plot Type, and this time I want to set up a bar chart. Okay, and for some reason it does a pie chart again. So let's try this again. Plot Type, and let's go to bar chart. Okay, looks much better. Now this bar chart once again doesn't help us because we haven't told the Inspire what the frequencies are for each of these. Remember, frequency is how many times something occurs. Relative frequency is the percentage of the time that it does occur. So relative frequency is percentage, frequency is the actual measurement, the actual number. Well, I don't want to do anything here yet, and this is just the way the Inspire is constructed. Do not designate a category or a variable for your vertical or y-axis. You have to follow this step first. So let's undo this and let's go back one more time and review what we did. I'm going to completely undo this, go backwards. So I hit Menu, sorry, not Menu, I hit Control I. Let me escape out of here. I hit Control I. I added Data and Statistics. I wanted it to do the day that births happened. I did not designate a y-axis or a vertical axis variable. So what I'm going to do is I'm going to go to Menu, Plot Type, and I'm going to go to Bar Chart. Now, at the bar chart, we have not told it what the frequencies of all of these births were. So it just gives me 7 bars of equal length, 14.3, because that adds up to 100%, right? Because we're doing kind of, that's the way it's reading it, is the frequency is 1. Well, now I'm going to go to Menu, I'm going to go to Plot Properties, and I'm going to add a Y summary list. This is just the function for you to do frequencies on the Inspire when you're doing a bar chart. So again, Menu, Plot Properties, add Y summary list. And what do I want to know for each day? How many births occurred? And there is your bar chart. And you'll notice as you mouse over, on Sunday, 7,374 people were born. Babies were born, 9.3%. Sounds weird to say people were born. They are people. They're little people. 9.3%. If you look over here, that's exactly what we have in our table. So this is your bar chart. And that's the way that you can do it. Now, there's different things you can do with the bar chart. I can go to Menu. I can actually go to Plot Properties. And if you scroll down here, you'll get absolutely nowhere. So let's see here. Settings. I think it might be under Settings. Let's try. No, let's see here. We'll figure this out. There is a way for you to actually categorize your data. Let's try Actions. Hey, we found it. Actions, you go to Sort, and you can go to Alpha Order, Value Order, or List Order. So my list order, how did I enter my list on the table? I started with Sunday, right? So if I hit List Order, it's already there. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Let's go back to Actions. And let's sort it again, but this time let's sort it by alpha. Now we've got Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. That doesn't get us anywhere either. So let's go back to Actions and let's sort it again, but let's sort it by value. Now you have the highest number of births and you can see it from highest to lowest. So there's different ways you can do this. But anyway, this is how you do a bar chart representation. So going back to number 11, would it also be correct to make a pie chart in this data? So what do you think about making a pie chart with this data? Well, this actually would be appropriate to make a pie chart for this. And the reason is we're looking at the births on the days per week. So we're looking at how many births occur in a week, and we're breaking it down into how many occurred each day. Remember, pie charts are parts of a whole. Parts of a whole. And I don't think you can go back here. Oh yeah, you can. Let's go to Plot Type now and let's choose Pie Chart. Now do you see how my pie chart values are accurate? So Monday, I had 11,704 births. That was 14% of the population. So hopefully this helps you actually set up the pie chart and the bar graph on the Inspire. So let's go ahead and move on. B says, suggest some possible reasons why there are fewer births on weekends. Now think about this. On the weekends, again, when you ask opinion questions like this, there's no real right or wrong answer. It is an opinion question, but it needs to be something that's reasonable that you can justify. Now, one of the best reasons is that C-sections are usually scheduled. And when you have C-sections that are scheduled, do you think a doctor is going to want to schedule a C-section on a weekend, maybe when that doctor can have the day off? Maybe they'd rather schedule it during the week when the doctor's on call. Sometimes doctors are not on call all the time, and when you have a baby, you want to have your particular doctor usually deliver that baby, but that usually doesn't happen. So anyway, that's a possible reason that you could state for that happening. Okay, so let's move on to the next one. So coming back over here, the next one that you guys had to do was number 13. So looking at number 13, we have a pie chart. And once again, it's a pie chart because we're looking at parts of a whole. You cannot do a pie chart when it's not parts of a whole. Pie chart means there's a full sample you're looking at, and we're looking at percentages of that particular sample. Age groups, not necessarily parts of a whole, depending on how you quantify it, but this is what we're looking at here. It's prepared by the Census Bureau to show the origin of the more than 50 million Hispanics in the United States in 2010. About what percentage of Hispanics are Mexican or Puerto Rican? So what you want to do in this one is you actually wanted to read the pie chart and be as accurate as possible. Obviously, using the naked eye, you're not going to be as accurate as you want to be, but we wanted you to kind of estimate. So let's think about this. This would be about 50%, right? So that's about 50%. And if I went here, it would be about 75%. My line is here. If I were to actually draw a line, which you didn't have to, but if I were to actually draw a line for 50% there, and I drew a line here that represented 75%, and I see that the Mexican population is here, wouldn't you assume that that's probably about that's a little more than halfway between 50% and 75%, right? So what we're looking at right here is I've got a 25% section right here. And this line right here is probably about halfway. So what would you give to half of 25? Well, half of 25 is about 12.5%, right? And so if this is 50, and I've got 50% over here, and I want to add another 12.5% here, which is half of 25, 50 and 25 would give you roughly 62.5 or about 63%. Now, did you have to be absolutely accurate? No, it's very hard. But it's easier if you redraw these and actually look at checkpoints like every 25%, because those are things for you to easily see visually. And so that's what we were looking at for number 13. Now, if I wanted to look at the Puerto Rican population, so let me go ahead and erase this here, and I'm looking at the Puerto Rican population, I can use the same kind of logic. So now I'm looking at the Puerto Rican population. This right here to this right here would be 25%. And the Puerto Rican population falls about right there. Now, the Puerto Rican population, that would be, if I went all the way up, where again, we just did that, that would be 13%, 12.5%, but it's even smaller than that. So I would say anywhere between 9 and 10%. And again, you just have to be close. There's no perfect right answer. So that was the answer to number 13. Okay, so what I'm going to do is I'm going to go ahead and I'm going to go back to full screen here. We don't need the calculator right now. So let's move along and let's go down to number 15. That was the next one. So number 15 is over here, and I'll go ahead and zoom in a little bit so we can see it. Buying music online, young people, whoops, sorry, the page marker's in the way. Buying music online. Young people are more likely than older folk to buy music. I love that, older folk. That's talking about people like me. I'm offended. Here are the percents of people in several age groups who bought music online in a recent year. Okay, so I've got the age group, 24% of people between 12 and 17 bought music online. 21% of people aged 18 to 24 bought their music online. 25 to 34 years old, 20% bought music online. 35 to 44, only 16%. And you can see as it gets older, it tapers off. So the next question is, explain why it is not correct to use a pie chart. Now let me erase these guys over here so you can see this a little bit better. Well, we're not talking about parts of a whole. This 24% is not 24% of all these people. I didn't take a survey or a sampling of 1,000 people and break them into age groups. I literally am looking at each age group as its own whole. And you can't do a pie chart unless all of your numbers presented are a part of a single whole. 24% is part of a whole, but it's part of the 12 to 17 years age group whole. I know I'm saying whole a lot. So this cannot be represented by a pie chart. These are not all parts of the same whole. Make a bar graph of the data. So let's make another bar graph. Well, let's go back to where we were. Let me set up my little tables here. And I'm going to zoom out right here if it allows me to. And we've got these age groups right here. So we can do the same thing. We're going to enter data and statistics. Now, when you're on the Inspire, remember whatever document you're highlighted within, that document is where the insert is going to happen after. So if I do this and I'm highlighted in document 1 and I hit Control Insert, do you see where it places it? So I want to add a new list in spreadsheet. Well, what's going to happen is it's going to insert it between my other 2 pages. I don't want that. I want to be in a new set of documents. So what I should do really is I should insert, let's see here, data and statistics. So I'm going to insert a new spreadsheet here. So column A, I'm going to call age group. Okay. Now, if I do age group, see how it highlights it? That means it's not going to let you do that. So I'm just going to do age GR. And we're going to call that first one age GR. I don't know why it's calling it age, why age group is not allowed. I think it has to do with the terms. And then the second one is going to be online. Okay. So I'm going to go through and I'm going to enter these values. Now, I've got to be careful because if I try to enter something numeric, it won't come across as a categorical variable. Now, this is a categorical variable, age group, that is numeric because we've got 12 to 17 years, but we're just talking about an age group. This is actually an age range. It's not a quantitative variable that you're going to add and subtract and divide and multiply. It's just a range. So I'm going to do this as age group 12. And I'm just going to say 12. I'm going to do the bottom of the age group, and I'll show you why in just a second. So 18 to 24, 25 to 34, 35, and I'm just choosing random names for this for me. You can't use numbers because it actually tries to store variables. So let's just follow me on this, and you can call it whatever you want, but I'm just making sure that these are all alphanumeric and not numeric. All right, so what percentages? 24 were online, 21% here, 20, 16, 10, 3, 1. Okay, so now Control, Insert, Add Data and Statistics, okay? And we want to add the variable down here. So I'm going to click on the variable, I'm going to add my variable, and my variable, remember, is age GR, not age group. Age GR, so there are my age ranges. Now I'm going to go to Menu, Plot Type, and Bar Chart. Remember, I do this before I designate the y-axis. Now I've got this, I go to Menu, Plot Properties, Add Y Summary List, and that's my online percentages, and there you go. There's your bar graph. Don't pay attention to the fact that you have 24%, but you have 25.3% in parentheses. Remember, what's in parentheses is only if this represents parts of a whole, but it doesn't. The calculator doesn't know the difference, so the calculator is just spitting out the data and represent the data you put in. So don't worry about that. But anyway, that's how you do the bar chart for number 15. And 15 with the bar graph. Once again, it's asking why you can't use the pie chart, not parts of a whole. All of these are independent percentages. Each group is its own whole. Okay, so let's move on to 17. Once again, let's maximize this window. I'm going to move on to 17. And 17, here we go. Going to school. Our favorite thing ever. So school students in a high school statistics class, always it's a statistics class, I wonder why, were given data about the main method of transportation to school for a group of 30 students. They produced the pictograph shown below. So the first question asks, how is the graph misleading? And a lot of you guys, I could tell that you had an idea of what you wanted to say, but you had a hard time articulating it. And remember, part of the AP exam is you have to be able to articulate, and you have to be able to justify and support what you're trying to say in a manner that the person grading your exam understands. So you have to be careful how you are expressing this. So I could tell a lot of you knew what you wanted to say, but you just didn't necessarily explain it in the best way. So here's some things that you need to make sure of. First of all, when you look at a pictograph, okay, the pictographs are not always accurate. So think about this. This talks about here, we have a group of 30 students, right? And this is the mode of transportation. So we have 1 cycler, 2 that took a car, 7 that took a bus, and 2 walkers. So every car is 2 people that rode by car. That's 1 person that cycled, 7 that rode the bus, and 2 that walked. Well, let's look at this proportionally. Proportion, that is the key term. Things have to be proportional. If this is half as big as this, when I look at the pictures, the picture for this one should be half as big as the picture for this one. But what you have here is something that's very inaccurate. This car represents 2 car riders. This bus represents 7 bus takers. If you look at this car, it's almost 3/4 of the way, if not maybe 2/3, 3/4 of the size of the bus. That's not even close to being correct. If I were to look at this pictograph by sight, I would say more people, the most people got to school by riding their vehicles. The second most rode the bus. In essence, what happened was I have 2, 4, 6, 8, and I'm assuming that's a half a car, 9 people that rode in the car. 7 and 7 is 14. 14 people rode the bus. Well, if 14 people rode the bus, why is it that the pictures of the buses are substantially smaller than the pictures of the car? If I were to look at this, my first instinct is to look at this like a bar graph. I'm going to assume that the car riders had the greatest volume, which in fact is not true. This is why the pictograph is misleading. The pictures are not proportional. Make a new graph that isn't misleading. I'm not going to do that for you here. But basically what you would need to make sure of is that every bus covered 3 cars and a half. So 3.5 cars should be the same length as a bus, because that would be 6 plus 1. That would be 7 car riders. So this right here, from here to here, should be the same length as 1 bus. So that's what you have to be careful of. Also, the cyclist is 1 cycler and the person is 2 walkers. Well, it looks like the cyclist, 1 cyclist is more than 1 walker. So again, those are not proportional either. All right, so let's look at the next one. Let's look at number 19. And number 19 deals with attitudes towards recycled products. What we're looking at here is we're buying recycled filters, and based on, we're trying to see what our sample population thinks about buying recycled filters. First of all, do they think that recycled filters are of higher quality, yes or no? And if so, do they buy them? So this is a two-way table. We've talked about two-way tables. Two-way tables are a comparison between 2 variables. So what we're looking at is we have row variables, which is, do they think the quality is higher? And we have a column variable, which is, do they buy the recycled filters? So the first question that it's asking you here is, how many people does this table describe? And then it says, how many of these were buyers of coffee filters made of recycled paper? So first of all, let's look at how many people this table describes. Well, remember, we've got row variables and column variables. So let's look this way. How many people thought the quality was higher? Okay, if you total those across, 49. Of the 49 that thought the quality was higher, 20 actually bought the recycled and 29 did not. So let's look at the next one. The same. 7 people thought that that the filters were the same. Recycled didn't make a difference whether or not they were the same as a regular filter. And so we had 32 of those because we had 7 say that they still bought them and 25 did not. Now let's look at the last one, the people that thought that the recycled filters were of lower quality. And we had 52 of those guys. Those guys, 9 of them said they did buy, even though they thought they were lower quality, but 43 said no. So this is creating kind of like our marginal distribution. And let's total across down at the bottom too. In our column variable, 36 people said that yes, they still bought the filters. And 97 said no. Now the bottom line is you've got two distributions here, and what you'll see is both of these guys actually add up to 133, whether I'm totaling this way or this way. So now that I have my totals, I can answer the second question. And the second question says, after we give the marginal distribution, what percent of the people in the sample think the quality of recycled product is the same or higher than the quality of the other filters? So let's do the percentages. Now this would represent parts of a whole. I can do complete percentages here because I have the same group of people I sampled and put them into different categories. So let's look at this percentage-wise. All right, let's look at how many people thought that the quality of the filters were higher. That would be 49 out of 133. So if I actually were to do that calculation, 49 divided by 133, that would tell me the percentage of people that actually thought that the quality was higher. And I'm going to do that right now, which is 36.8%. So 36.8% actually thought the quality was higher. How many people thought the quality was the same? That would be 32 out of 133. So if I do 32 divided by 133, I get 24%. So 24% thought that the quality was the same. Now the question is asking you, what percent of the people in the sample think the quality of the recycled product is the same or higher? Well, all I have to do is consolidate these two percentages. I have 36.8 and 24, and when I add those guys together, I get 60.8%. So roughly 61% thought the quality was higher. So that's how you create and use the marginal distribution.